Okay? Number 29. F of x is equal to 2x plus 5 over the square root of x. And this little piece of ugliness here, we're going to rewrite that so we can use the rule of box for this. Otherwise, we're going to have all kinds of things that we don't want. And then we can, if we have to change it back to that, that's fine. But I'm going to rewrite this as x to the negative 1/2 power times all of this, which is 2x plus 5. Okay? So now we can go ahead and take the derivative of that. And so we take x to the negative 1/2 times the derivative of 2x, which is 2, plus 5, which drops out, plus, because we're multiplying instead of dividing, and this becomes 2x plus 5 times the derivative of that. Well, the derivative is going to be negative 1/2 goes in front, and then this becomes x, and then we subtract 1, which is 2/2, so negative 1/2 minus 2/2 is negative 3/2. And that is how we're going to start this. Now, we're going to go through and resolve all this. And so this is going to give us 2x to the negative 1/2 power plus, and I'm going to multiply this across both of these, which will give me negative 2x times negative 1/2x is just going to give me negative x to the, and this is 1 plus negative 3/2, which is negative 1/2. And we have 1x is 2 times negative 1/2 is negative 1. So that's where the negative sign is coming from. Plus, and or actually this is going to become minus because we've got a negative 1/2 times 5. So that's a negative 5/2 times x to the negative 3/2 power. Okay? Now, what we're going to do at this point is we're going to combine these two together. So we have 2x to the negative 1/2 plus negative 1x to the negative 1/2 power. So that becomes just plain x to the negative 1/2 power minus 5/2 x to the negative 3/2 power. Now we've got these negative exponents that we need to get rid of. Well, we already know this is established 1 over x square root of x. And this is going to be equal to 5 over 2 times square root of x cubed. Well, it turns out we can resolve that because this is the same thing as saying 2x to the square root of x. Okay, so, and the reason why you do that is that's a 3 there, and for every 2 x's you have in there, you take 1 out and leave 1 behind. So that's where we get that answer from. So, now we need a lowest common denominator here, which is going to be 2x square root of x, because this square root of x is found completely in this. So square root of x goes into this exactly 2x times minus, and since this is already the denominator of this right here, and this becomes 5, and now we've got no negative exponents and we have no fractions within the fraction, so there's our answer right there. Number 31. We have h of s is equal to s cubed minus 2 squared. That's the problem. Now, we haven't done powers of power yet, or powers of, a rule of powers of power, or whatever you want to call it. We will get to that eventually, but for right now, we're going to rewrite that as a product of two of them. So this is going to be s cubed minus 2 times s cubed minus 2. All right, so that means we're going to find h prime of s, and it's going to be this times the derivative of this, and this times the derivative of this, which means we'll get two of the same thing. So I'll just put a 2 right in front, and we're going to get s cubed minus 2 times the derivative of that, 3s. And the 2 there is because we're going to get it twice, we're adding it together, so that's where I got that from. I go ahead and multiply everything through. Go 2s times, or 2 times 3s is 6s. 6s times s cubed minus 2 becomes 6s to the 4th minus 12s. And there is your answer. Wait a minute. Yeah, that's, oh, this is, yeah, 6s times, yes, that's correct. Okay, 33. We're given here that the f of x is equal to 2 minus 1/2, 1 over x rather, over x minus 3. Okay, so what I'm going to do here is I'm going to try and resolve this complex fraction into just a fraction. And this is going to give us then a lowest common denominator up here of x. And then this is going to be x minus 3 down here. The denominator of this is 1, so 1 goes in x times 2 is 2x. X and then minus, x goes in x 1 time, 1 times 1 is 1. That gives us that. Now, here's the situation, and I'm not sure how familiar you are with these situations. We talked about it in chemistry when we had meters per second, or I'm sorry, moles per second, and then divided by m's and all kinds of stuff, and how denominators in combination become one denominator. Now, I can show this by saying that this is this divided by that, and then this becomes 1 over x minus 3 when you multiply it, and so these two become the same denominator. So this becomes 2x minus 1 over x times x minus 3. And then we resolve that, and that's going to be equal to 2x minus 1. And then this becomes x squared minus 3x. And I'll let you do the rest on that, I mean, if you want to do that. But this is how this starts. Then you just go through the same process as before. I want to jump to 37 because it looks like it's going to be confusing, but it really isn't. It isn't a bad problem at all. This is f of x equals x squared plus c squared over x squared minus c squared. Okay, so there's really, I mean, there really is no way of rewriting it. It looks like it could be, like, that's probably why they put this in here, but you cannot factor that out. This you can, x minus c, x plus c, different squares. This you cannot. So we'll just go ahead and find the derivative straight out of that. And so, and I'll start it, but I'm not going to finish it because you can do this. After you've done this a bajillion times, this is pretty easy. But this is going to be x squared minus c squared times the derivative of x squared, which is 2x. And since c is a constant here, that drops out. Minus, because it's dividing. And then this becomes, oh, I'm going to put that in parentheses there. And this then becomes x squared plus c squared times the derivative of x squared, which is 2x, and negative c squared is constant. So this would give you the opportunity to finish this up. And I think you'll find that the x cubes that you're going to get are going to cancel out. and the C's are going to remain high. Okay, so your assignment is on page 126. Problems 26 through 38. Okay, good luck.